Hello and welcome to the ACCE Learning Network Hangout. This is Series 4, Episode 20 for 2014. Hi, Amanda.
Hey, Roland.
It's a place we can connect the network of our PLN.
And as usual, if you're watching us live, you can post a question to our panel by going to todaysmeet.com/ACCELN. And on Twitter, you can use the hashtag ACCELN.
Thanks, Amanda. I'm Roland Gesthuizen, a high school teacher, e-learning leader in Victoria, Australia. I'm also on the DLTV. It's been a roller coaster week for me. A really good friend and mentor, Peter Barrow, passed away, and he was a chap who first, I guess, recruited me as a science teacher in Victoria. I was bright-eyed and bushy-tailed, making the move from the mining industry into education, and he managed to pick up on my IT and marine biology backgrounds. Remember the first conference I went to, Peter made the comment that every teacher had to write a paper, and so I was furiously doing that. That was a bit of a lark when I sort of rolled up and discovered that no, teachers don't have to write papers for conferences. They can sit there and eat all the nibblies and steal all the pens. But it was a start of a long journey, and ever since then I've been presenting at various ACEC conferences. Speaking of which, little plug for ACEC 2014. Amanda.
There's about 4 weeks to go now, if I'm counting correctly, and 1 day or something like that. I'm Amanda Rablin. I'm an e-learning coordinator in Brisbane and a proud QSite member. This week has been a different sort of roller coaster for me. I feel like I've spent most of the week baking, icing and sculpting and creating an adventure obstacle course. That's because my little girl turned 3 last week, which was pretty awesome. A chance to, you know, unleash my baking skills.
Very talented, Amanda.
Oh, thanks. You're too kind. And we have some wonderful guests joining us on our panel this evening. Now, I noticed Janine has only just joined us, so how about I let you do your wrap-up at the end, so you're welcome at the end, so that you get a feel for it before we throw you in the deep end. So, Jason Zagami, would you like to introduce yourself?
Hi all, Jason Zagami from Griffith University, where I investigate all things to do with ICT.
Fabulous. Jenny.
Hello, I'm Jenny Ashby from Bendigo in Victoria. I'm the leading teacher and ICT do everything person, and I also do reading recovery.
Fabulous. And Wes?
My name is Wes Warner. I'm the head of ICT at Genesis Christian College on the north side here in Brisbane. And my week, well, we've finished off the senior school in our Minecraft world, and we've started on the library today. So that's pretty amazing there, but the map's getting too big at the moment and getting a little bit laggy, so we might have to start a new map.
Oh dear, different one for each school, huh? Each area of the school.
Each campus.
And Janine? You might need to unmute yourself first. Go.
Hello, I can hear you, Janine. I can hear you talking.
Oh, I can't hear her.
No, I can't hear her.
Yeah.
All right, we'll have to do it by interpretive dance if you can't get your microphone working. You're welcome to try some technical problem solving along your way, and just let us know if you need to test your mic. That's fine. Okay, well, this evening we're exploring things Papert, and we've called it Papert's Turtle, unlocking computational thinking. And I have really fond memories of creating with microworlds when I was at uni learning how to be a teacher. And it was a lot of fun, but it was also when I was first introduced to Semour Papert through the lovely Marg Lloyd. Shout out to her if she's watching. How about you, Roland? You're probably a similar vintage to me in terms of, you know, your first term.
Actually. But I often sometimes wonder where I spent my misspent youth. I played with real turtles and threw sticks around and pretended they were boomerangs. But I was really lucky at my first conference, Amanda. This was an ACEC conference in Melbourne, and I was introduced to this bearded, grey-bearded chap that everybody was just so excited about, who liked the little email system that I was running on my laptop. I had no idea this was Semour Papert. I had enough trouble trying to decide what was a good lesson plan and try to work out how to integrate my knowledge of industrial computing into a high school. And now looking back on it, he was a genius in the way he was thinking about how kids think. So it's been really good for me to sort of think back and look at the impact that this person had on the way that laptops were evolving. I think at the time he was talking to some students from MLC who were developing a laptop program, and there's also a wonderful educator called Gary Stager who's doing some work with that group. Heady days. Wes?
Sorry?
When was your first Papert experience?
Oh, well, yeah, I sort of missed it in my undergraduate days, and it was only later on that I started seeing introducing Logo to the students from that point of view. So from a coding point of view, and we still use Logo to this day with our Year 8s. It's very good for their logic thinking as an introduction before they get into any of the heavier programming that we introduce there at the school.
So what kinds of things do they create with Logo?
Well, I can show you. I'll just share my screen here.
That would be awesome.
This was... not that one. Are you getting that one now?
Still you.
Cameras?
Yep, that's it. And share. There we go.
Yay.
So this is done in the first week of using Logo this year in Term 2, and it was a sword that was created by one of my Year 8s, and although the coding was quite spaghetti-wise, he had a really good grasp of moving the turtle around and also using the fill color, using the pen up, pen down, and he said that he took probably between 45 minutes to an hour to create that sword before going and looking back at that and said, well, okay, I can fine-tune that and make that a little bit more tidier as a result by using the loops and things like that within there.
I love the Game of Thrones theme there. Is that something that the kids relate to in your class?
Not quite sure. I think it was more of a Zelda theme. But that's one of the things, and the other thing that when we are starting to look at nesting our code within that in Logo, there's a great little example where I get the kids to code a particular sequence and then run that, and we test the speed of that, and then we start doing nesting and we run the same code, and it's almost instantaneous. I actually do have a link on my YouTube channel which I can post a little bit later to show you the example that I do give to the kids.
It's interesting. One of the ideas that Papert put forward was that children should be programming the computer rather than being programmed by it. It's something that I think we're still trying to come to terms with, because I keep seeing us coming with the idea that it's some sort of content delivery tool. And is there enough of emphasis in the way that we teach programming? Because even if you break this down into an incremental series of steps that you progressively work through, the kids aren't really learning programming, they're just simply following this recipe-like instruction. How do you approach that, Wes, when you do it? You throw up a challenge for students to make something and then to have a go at trying to work out what program was right?
Yeah, like, let's take for that example with the sword that my student put up there. I put it then back onto the class. I said, well, okay, that's good, but the coding is pretty sloppy. So let's look at trying to improve that code. And so they worked in groups to sort of come up with ways of nesting set parts of the code that they could say, well, okay, that's repeating there, so let's put that together, and they improved the code. But each group came up with a different iteration of it. Neither one was wrong, but each was a little bit more. One was more efficient than the other, and that was the whole point of trying to get that across with the kids with the coding, is to say, look, try to get as efficient as possible.
So what's driving the learning here? Is it the program, the machine, or perhaps the curiosity of the child?
Yeah, well, it's interesting. Like I always try to, get the kids to come up with, different patterns or different scenarios, rather than just like relying on the same thing year in, year out. So each group that I take through will, come up with a completely different, project to sort of come up with.
I think we need to throw to our resident academic as well, because Papert has written a lot of papers too. So, Dr. Jason Zagami, when did you first learn about Papert, and how has that influenced your career as a teacher, academic, computational thinker?
Well, I certainly was influenced by Papert long before I actually knew about him. In my own high school experiences with computing, we had a Logo turtle, and getting into Logo language was one of our experimental experiences with computing, particularly the creation of artworks, and with the spirograph turtle pens, trying to do that sort of approach. But probably I first became really aware of Papert was through the MIT Media Lab and the lifelong kindergarten approach there, and some of the work I've been doing exploring different ways of teaching, and getting back to the actual, well, back to the student as the center of the focus of the teaching and of the learning that's going on, where it's all about their experiences with the learning space, and using code or Turtle or Logo, or more recently the Lego Mindstorm kits and so forth, as ways of exploring the world. Because I think that's where Papert's real work is focused. It's not at all from computer studies. It was from psychology and through learning development. And he just found these tools and decided to see they would actually help students explore and learn, and took it from there.
Funny that you mentioned, Jason, the drawings, because I think sometimes his work was misconstrued by some as just Logo, a nice language for drawing pretty patterns, without realizing that he was actually looking at the thinking process and the idea of computational thinking, a term that Papert came up with. Do you think enough people actually read the Mindstorms book rather than buying the toys?
He didn't quite come up with the term computational thinking, although he certainly came up with the idea of computational thinking. He didn't name it that way. In Mindstorms, he used some other words to describe it, but he was describing what we now refer to as computational thinking.
Do you use the word algorithms?
It was algorithmic thinking was certainly part of it, but he was much more interested in thinking processes than in the actual language itself. The language was just the best you could do with computers at the time, and so he was using what was available.
And I think the questioning that he brought to interactions with students, I remember watching some videos of him actually talking to students who were creating and exploring different things on the computer, and he would just ask them questions about, what are you doing here, and what are you trying to get it to do? Is there a different way you could do that? And just unlocking that thinking within the child. That's really powerful to see as a teacher.
That's really dangerous words, because the idea that the learning will occur without the direct intervention of the teacher, that's almost heresy for the way that some schools operate. The teacher is the main steerer of knowledge, driver, and the whole point of this teacher accreditation assessment is that Without the teacher, no learning can actually take place. Well, the reality was under that conceptual model that Papert had, children will develop intellectually without actually being taught. Perhaps that we need to look at taking some of the brakes off in the way that they can learn, look more towards challenging and inspiring students rather than providing this very structured scaffolding for content delivery. How did we miss that for 2 decades when we were playing with Turtle and with the Turtle robots and with the programming?
I'm not sure Papert would really be described as advocating a teacherless classroom. He certainly was very interested in student learning and the ways that they go about learning. And I think he did see teachers having a role in that. Just the technology assisting with that process of allowing students to explore. Because probably his biggest claim would be the constructionist approach, where students constructing knowledge and constructing ideas and exploring through that process enables their learning and the deep thinking to occur.
Now, constructionism and constructivism are always confused. Jason, do you want to have a go at actually unpacking that for some of the listeners? The difference between constructionism and constructivism?
Well, constructionism is basically where students actually create something. Most often with the stuff we see is with computer code or robotics or Lego robotic kits and so forth. And that facilitates the learning process. Constructionism is quite a lot more complex and is a whole learning theory that's evolved over a long period of time. And certainly Papert's had some work with that, but his real claim is the constructionism approach. Constructivism is much more nuanced and well established. But I find most people don't really understand constructivism, because they don't take the first step of deconstructing knowledge. In order to construct new knowledge, you have to deconstruct your previous understanding of a concept. And that's a step we don't often see in a constructivist approach. But that's quite different to Papert's constructionism approach. And I'm sure that makes it no clearer.
Jenny? we say go read the book. Jenny, you were mentioning in the chat here that a bit about the once the kids have a range of instruction and constructs of sequence, selecting and repetition, they can focus on solving problems as efficiently as possible. And her first experience of Logo was the Tasman turtle in the early 80s. Jenny, I've actually got some pictures of the Tasman turtle here, so I'll just screen share them.
I didn't actually use that Tasman turtle.
I think Roland is being Janine's voice.
All right.
We've got too many gay people today. Oh, wow.
So here we go.
That's really cool.
So here is, I think that's a cover of a book actually, a turtle robot, Tasman turtle, drawing a turtle. It's been constructed. I could have done a better circle of that with a few more repeat functions. And here's another Tasman turtle. I think that's an Apple IIe computer. Could be the Euro Plus model. Probably purchased by the school by collecting Safeway shopper dockets.
Yeah, it's not a Apple IIe we had. Doesn't look like it. Mm.
Yeah, someone's got a very cheap TV on top. It's not the Apple TV either, so it's going to be a very old one.
No.
And you can see the parallel, or would that be a serial cable? You think serial cable interface?
Wow.
I think of how the Apple IIe was using serial interface, perhaps even a cassette tape drive. Here's another view of the Tasman turtle.
It's very nostalgic.
Ken, you want to mention a bit about it? Just noticed looking and scratching your chin there. What was the history of the turtle? I mean, Tasmania was really cutting edge there. He's just popped into the chat. Alan Branch and friends actually made this turtle. And Janine, who's also lost the audio, mentioned that Sandra Wills was an advocate in Tasmania at the turtle and logo. And I believe she worked with Papert at various times. And some of the history I had with the Tasman turtle in the early 80s, there was an ACCE conference, and I remember that there was a member of the computing education group of Victoria, and very keen to try and get Papert involved, and was able to use one of the turtles as a way of hooking his interest in what we're able to do here with programming and engaging kids with the real world. And for me, being able to actually connect up the physical device, so it's not just throwing out your output onto a screen, this is actually physically interacting in the world, was really engaging. You can imagine if you've got a box like this thing here, and you're able to sort of steer the wheels around, you may be drawing with a pen, but perhaps you could also be working towards an amateur or an arm, or being able to build something. And that's really quite powerful, to put that kind of technology in the hands of kids and getting people to think about computing beyond just simply producing pretty pictures, noises, or graphics on a screen. Jenny, you made mention of something called a B-bot, and I've got a picture of a B-bot here. I'll just throw it on the side. Can you explain what the B-bot is?
A B-bot is a little like a bee without wings, I guess, and it has some controllers on top with your forward and your back and your left turn and right turn arrows, where you put your input actually on the B-bot itself, and you press where you want it to go, and then you press go, and the B-bot travels along in the directions that you've told it to go. And my first experience with Logo was in the early 90s, and it was with Dr. Graham Perez. Is that how you say his last name? Perez? Yes? Graham Perez? And I did...
Not to be confused with the Black Eyed Bees B-bot here.
And I did Logo Writer and Microworlds then, and I can remember a student who was probably in about grade 4 who did a whole procedure and sub-procedures to draw a semi-trailer truck. His dad was a truck driver, so he had a procedure for wheels and procedures for door, procedure for window, and for the tray on the back, and then he would type in, at the end of his whole logo, he would type in truck, and the whole truck would be drawn on the screen. And it was, you know, a real feat for him because he had quite a few literacy problems, and he just stuck at this and was amazing. And it really opened my eyes to see what something could do for other people. And then I've sort of put it away for many years and just got it out recently, and thinking I love this when things come around full circle.
It's interesting when I'm teaching the students to program in the, what are we teaching them? They're exploring programming with the Grok Learning Challenge. They don't get it right. In fact, it's often better when they're learning the programming by kind of breaking the code or getting it wrong and then continually making adjustments and changes and getting that immediate feedback. Is that what's so cool about this kind of approach for learning, that they get a very tangible physical movement from these turtles and drawings, and they can visualize the things that might be happening in their code and adapt and change their thinking and solving the problems?
Yes, that's exactly it, Roland. The immediate feedback and all the debugging that you have to do to make it do exactly what you want it to do. So with each error, you actually learn something and adjust your next command. So it's a great way to learn. And in those days, we didn't actually use cards that were all written out and they copied it in. It wasn't, and even the scratch to me is really dumbing it down, because you're just dragging blocks and putting them in and typing in numbers sometimes. So I wonder sometimes about these things, but I guess it's giving them a start, although my little preps have been able to write their own code and put FD and LT for left turn and write some code out and get someone going from one side to another and around the room without having to use blocks.
And Ken just made a comment here. It's a full circle indeed. He had a conversation with a teacher who is using a S04e20 robot ball to do what was being done about 30 years ago. And Wes made the comment there about the next robots learning by failing. Say, Wes, is that really what we're teaching, learning by failing?
Well, failing is probably a harsh word, but when you look at it, but it's learning from your mistakes and and making those slight improvements. And when the collaborative nature of coding gets together and they can sort of say, well, okay, that wasn't quite working. We're busy in the first Lego League competition at the moment. Got the mats all set up now, and the kids will be coming together and looking at breaking the entire project down into small parts and seeing how to best approach the problem. And inevitably they're going to run up alleyways that are just going to be prove to be dead ends, but the knowledge that they get from that is the next time that they encounter something along those lines, they can draw upon that knowledge and apply it elsewhere.
So a master programmer isn't someone who just gets it right the first time, sits there and...
Does any programmer get it right the first time?
That's why we have version 1, version 2.
Right. I used to write lots of loopy code in maths, and it took me often many more iterations what the teacher could do on the board to solve my maths problems.
That's why we have beta, everything running in beta for a while.
I tried to explain it with maths, but it had the right answer at the end.
Well, that's why we have Mac OS 10. We have Windows 8.1. We have Ubuntu 14.4. So it's constantly being updated, iterated, changed, altered, to suit the needs.
Brings me to something I think Papert once said, that the question is to ask about the program is not whether it's right or wrong, but if it's fixable.
True. Just going back also with Ken was talking about with the S04e20 there is it's an interesting device that can be used with a HTML programming language called Touch Develop, and you can actually write scripts to then interact with the S04e20 itself. So you're not given a device that can just do one thing. It's up to the students to sort of come up with different ideas and ways to interact with the device itself. So you may have it as a ball that rolls around the ground that can be controlled by your iPod or your iPhone, but other people have come along and said, well, okay, here's a device that has a gyroscope in it. Well, I'll make that the controller for my game. So you've got this ball in your hand, and when you move it left or right, your icon on the screen will then move left or right according to the S04e20.
I'll share a picture here of what the S04e20 actually looks like if anyone's curious.
Yeah, I've
this is a S04e20. Here we go. Is it up on the screen? That's a S04e20.
Looks similar to the other ones we saw.
This reminds me of a cartoon with a hamster that runs around inside a ball.
It feels like it too.
It's interesting, the Roomba, which is that vacuum cleaner that rolls around the house. Good friend of mine, Paul, has one that he uses with his house, and I think the cats like playing with it more than the laser he's got. But the interesting thing, I wonder what would happen if you were able to sort of program these kind of devices and think about the algorithm. How could I clean my house? Well, what kind of thing could you do with a ball? How could I make it roll along a path?
Yeah.
When I first got a Scuba, which is the mop version of a Roomba, it actually was really interesting. It had 3 different algorithms, and I spent ages just looking at it, wondering when is it going to change to the next one? It's randomly assigned. It's about to hit a corner. What's it going to do? I didn't draw a diagram or, work out the code or anything. That would have been too nerdy.
The obvious application is to paint it red and put a few stitches around it.
We get quite excited with quadricopters at our school, but what's that thing with the 4 legs that you can now buy and assemble, and you can then program it to walk around?
A dog?
It'll come back to me. I just saw there's a wonderful website called the Instructables. It celebrates some of that maker culture where you could make these crazy inventions and put them up, and there was a voice-activated 4-legged beast you could build. It was programmed with an Arduino device using Python. Really gorgeous. And that's something too, I think, that I can credit maybe perhaps Papert with, is this maker culture. Could I give him credit for inventing or stimulating a culture which is encouraging people to learn by inventing?
Mm.
Ooh, hang on, that's Gary. Sorry, Gary. I wasn't finishing the title.
Oh, I think Gary would acknowledge Papert's influence.
I think he does all the time.
Oh, and Janine's posted a lovely quote there, searching the archives of AEC, and she's got a lovely paper there from Logo to Boxer, a new computational environment in the AEC journal. And Jason, that's we're actually going backwards gradually, putting all of our past journals up on the web, I noticed.
We are, and Papert's paper is still by far the most cited paper from the journal, by several orders of magnitude.
Oh, lovely. Now, Amanda, we planned at this part of the tonight's session to do something a bit more challenging to our guests and sort of quote papers and citations and
we would never be such
Papert.
troublemakers.
I'm going to ask you to traumatize us now. Listen, we're problem solving. Just to make it a bit easier for our panel members, if you check the show notes, you'll have the link, and I'll do the same thing for today's chat room. I'll encourage you not to scroll down too far and cheat. We're going to work along here and see how you will rank up with your computational thinking. The link to use for anybody else who may be listening is www.bebras.edu.au. Okay, Amanda.
All right, so I think it was today marked the start of the Bebras challenge, and we actually have some Year 3 and 4 students at my school doing this, so it's very fun. Anyway, if I scroll down the page a bit, you'll be able to see a little bit of info about the challenge, but there's also some sample tasks. So this was Roland's idea, just to clarify. Yeah. But what you'll find here is this is the sample task for the Year 3 and 4. Can everyone read that okay? Do you need me to make it a bit more better to view? That is proper English. Okay.
That looks fine.
All right, so the first question is Captain Jack Beaver, because Bebras is, I can't remember what language, means beaver. And so all of the questions in the challenge have a beaver as a character. Okay, so he found the lost treasure on the secret island. He wants to tell his pirate crew on his ship, the Blue Pearl, to come and help him bring the treasure on board. He uses the secret pirate wave code to contact the crew. He creates different types of waves, which all his pirate crew understand. He sends the following waves to the crew. What is his secret message? So you'll see that there's different wave designs there. So our challenge to the group is, which one do you think he sent by looking at the diagram?
I thought this was a quantum wave problem, but I'm coming at it from the wrong side there, Jensen. There's more than just a binary message here. We've got 3 different signals, haven't we?
Mm.
Come on. This is pitched at the years 3 and 4. We should be able to use that clip.
Hurry up. Hurry up. I found the treasure.
Hurry up. Hurry up. I'm waiting on the iron.
I'm waiting.
But you just left it. You just went from left to right. Is that really solving it?
It's reading, it's interpreting the code. So
Well,
yes.
someone with an Albert background is reading from right to left.
Good point. But the answers are written in English from left to right, so maybe they make allowances for other languages. So yes, the first option is the correct answer, because you'll notice that the hurry up waves repeat. It'd be really tricky to send via waves to your ship. I'm doing actions, and then I realise you can't see me on video. Awesome. Okay, so the next question is 5 and 6. Just going to minimise, shrink the screen just a little bit to see if that helps. Just in case anyone's trying to read it. Okay, so this one's a bit more complicated. It's aimed at years 5 and 6. And it essentially, the Beaver Samurai of Japan built a network of beacon stations, and the summary is that the stations are shown as circles. If 2 stations are connected by a line, that means they are neighbouring stations. When one beacon is lit, it takes a minute for it to go to the next station, and then they ignite the fire on their own, and then it goes across the network. So after the sequence is repeated, and the sequence is repeated until all of the beacons light up. One day the beacon indicated with the large black circle is lit, and how many minutes does it take until all of the beacons are lit? So you have to follow the network nodes to the beacons and work out how long will it take.
I reckon if I rotate that by 45 degrees, we've got the DLTV logo for our new organisation.
Almost.
Almost. I guess
got a little bit of Adelaide as well, I think.
Yeah. So in a way, it's another wave it's propagating out, isn't it? And you almost have to work out the longest path. So how many would that be? 5, 6, 7, or 9? I'm checking the Today's Meet chat room. We've got a couple of people there. Double the first message, says Paula. Ooh, hang on, what was the first message? It's the second one. Does that mean she thinks it's a 4th one? Let's have a quick look. 9 minutes? Or maybe she means double the first one. 1.
I want to choose a raise.
What? I presume I started from this black one, so I'm counting 1, 2, 3, 4, 5, 6 minutes. I've got, so 6 minutes?
I've got 6 minutes too.
Yeah. 1,
Anyone
2,
have anything different?
kind of moving away down that stem there. Okay.
The top's too short. We ignore that and go to the next one.
Yeah.
What would be a really great challenge is to write a computer program that works it out.
Yeah, that'd be awesome.
Oh, that'd be tricky. You'd model it, or you'd have to break it into. It's not quite a travelling salesman problem, is it, Jason?
No, it's not travelling salesman, but it's a search process. You'd probably put it into a matrix and use that process.
Well, that's your task for the rest of the Hangout, to write that code. Go.
This actually is pretty close to how GPSs often work in street navigation, because they see them as connections between points with straight lines. I once got stuck at a cemetery because of one of those line segments was incorrectly recorded. It's not calculated, it's actually a distance recorded between 2 points, and which meant that every time I arrived at my destination, it was quicker to take a shortcut back through the cemetery and loop back where I came from. I was stuck in Fort Collins driving in circles until I figured out there was a GPS map bug.
Did you send the feedback to the developer?
Thank you.
Who's ready for 7 and 8?
Okay. Ooh, this looks. I can relate to this one. A flowchart.
Yeah, okay. So in school, beavers make complicated calculations using this flowchart. They begin with a number at the start and follow the instructions. When starting with the number 18, what is the number when finished? This one might take a little longer. I'm not going to sing hold music. I'm going to double check.
We're not going to get through. We're on our own, guys. Janine and Ken. Now you're the quiet two. We're going to read out your answers. We've been queuing enough. We've got the keyboards there. Let's see what Tasmania can do. And those turtles in Tassie have been doing their hard work at raising the computational thinking of Tasmania. Let's go. Janine's suggesting it might be 2, which is save. Ken's thinking about it still. Ken's typing away there. Maybe he's typing up the number 1, which would be the blank one. No, I didn't read it. There's that. What do you think, Wes? We vote for number 2?
Yeah, I'd root for 2.
It looks like something that Sheldon had on a whiteboard with how to find a friend.
See, I got 1 when I did it, so I must need a refresher or have to do it again.
When we're doing computational thinking of flowcharts, we do a lot of this problem solving, but do we actually get the kids sometimes to generate these flowcharts and to have a bit of fun with it?
All
rather
the
than
time.
solve a problem with a flowchart?
Is there anything more fun than making flowcharts?
I do this with my VCE students, Amanda. We look at how you might create an online community and have a login process. And there is a logical series of steps that you go through to authenticate a user and then give them access to a membership area. And if they fail that authentication, where they go back to in that flow. And there's a sort of an intuition that kids have in how it does. Ken made a comment. He says it looks very much like the basis of a conjecture that, as far as I know, has never been proven. The conjecture being that all starting points eventually collapse back to one pattern.
And we'll give him to the rest of the Hangout to work out the mathematical patterns and explain that as proof.
I remember that somebody once said, inorganic chemist, like my original training, try to fit y equals mx plus c to every phenomenon in the universe. We just have to change the axes to get what we want. Let's roll on.
Now, Ken, I think your audio might actually be working if you wanted to say hello.
I'm just holding some wires together here to make it work. So I think you can probably hear me now.
We can.
In relation to the flowchart stuff, I've just been doing some work over the last couple of weeks with some teachers who are beginning on the digital technologies curriculum. And we found from a flowcharting point of view something that we'd probably suspected for years with kids, and that was that teachers are much, much better at playing with a faulty flowchart and fixing it than designing one from scratch. And the one we used, I think, is the I'm glowing in the dark here. It's the radiation down here in Tasmania. The one that we found useful was the algorithm that traps your ATM card after you make 5 or whatever incorrect PIN entries. And so we had quite a simple flowchart that had an error in it, and it was really interesting to work with the teachers involved to try and suss out the the problem with that flowchart. They found that much more simple than trying to write a flowchart from scratch because of all the initial conditions and so forth they had to consider. So I suppose like with programming, it's easier to fix things than it is to design them from scratch. Certainly the case with flowcharts, to actually analyse what was wrong with a flowchart rather than build one from scratch.
Oh, that's a good idea. I remember once discovering the complex flowchart that actually determines how vending machines operates can sometimes be programmed incorrectly because there's a particular sequence of events they have to reject, change, reject the wrong currency, or also reject the coins if insufficient coins are actually insert the machine. It's quite a complex decision making before you get your can of lemonade when you put the money in the machine. Now, I recommend that we should have a jump to the very last one and just see if we can actually graduate from this school. Let's have a look. This is the year 11-12 beavers.
I couldn't do it yet.
Well, let's see if we can all help you then. We're on the last one here.
Okay, so the beavers are playing with a magical machine. It is composed of glass bubbles containing coins. The bubbles are connected together with big push buttons, and there's a picture of the magical machine underneath. If a bubble has an arrow coming from it, it is called a source bubble. If it has an arrow going to it, it is a target bubble. A bubble can be both a source and a target for different push buttons. When one of the big buttons is pressed, two things happen in the order below. The machine checks that there is at least one coin in all the source bubbles linked to that push button. If check 1 is true, a single coin disappears from all the source bubbles and appears in each of the target bubbles for that push button. Example, if push button B is pressed, one coin will move from the top right bubble and appear in the bottom bubble. Interestingly, there is a sequence of button pushes that ends up putting the magical machine into a stable state. In this state, no matter which button is pushed, nothing will change. Which order of button pushes leads to this stable state? I tried it and my brain went, ow. But I think the experts here can work on it. Oops.
Start from the stable state and then work backwards to get to here. Would that work?
That would be a good idea. And anyone want to think through their thinking, or is you too busy?
The machine checks at least one coin in all the source bubbles linked to the push button. If check 1 is true,
I'm trying to determine where the initial coins are.
The ones with the 3 dots.
Yeah, the dots are the coins.
Okay, so right.
So if you press,
you've got to start with a B.
Yeah, so you've got to start with a B, okay, which puts all the coins into the other bubble. Is that right? So you press button B.
Just one.
Put one coin.
Yeah. So it goes into all of the available source buttons connected. Target buttons connected to the source button, connected to bubble, connected to that button. So in B, there is only one direction of coin flow from bubbles.
The machine checks if there's at least one coin in all the source bubbles linked to this push button. It is true. It is false. So if check 1 is true, a single coin disappears and appears in each of the bubbles for that push button. But if it's false, what happens then? If check 1 is false?
So I'm trying to work out if you put a coin into the bottom receptacle, won't it then automatically go to A?
I don't know. Will it go to A or C?
Oh, no, it would only go.
First?
Okay, no, it'll only leave. Okay. So we've got to get a.
Yeah.
Would it be the fourth one?
Trying to rely on us, guys. So don't expect any online help. You can ring a friend if you like.
Is it the fourth one?
What makes you think the fourth one?
The reason being, okay, B, when you press B, so the coin will go down to the bottom one, and then
Yep.
press C, then it will just zip off over to the left. So you've got one there, but you've still got two sitting up in the top right. So you press B
Twice?
twice, so you'll end up with both those coins sitting down the bottom. And then you press A, one will shoot up. Oh, hang on. Oh, I've lost my
Where's it
thought
going?
now.
Left or right?
Now you
It
can't
can go. It will go into a stable position. No, it won't be. No, that won't be working. BC, BC. Oh, it'll be
So
third one. BC, BC. Then there'll be two sitting there, and then B. And A. Yeah, no, it'll be the third one.
Yeah,
So
'cause
Definitely the third one.
BA. B, C, B, C, which
it's picked two in the top
Draw-
right.
A
Get
will
a
flow back
pencil.
on each button. Okay, I think you got it.
So get a pencil out and run it that way. So that way, that's always a really good way of working an algorithm, is getting your old pen and paper out.
Yeah.
I reckon if they let me play the sink and make some bubbles, I could do it.
Would the bubble pop if you put a coin in
Get the
it?
real coins out.
So in this case, the way to solve it would be to actually play with something like you said, pencil and paper, being able to roll it through and testing the different combinations. Because it'd only be maybe 4 or 5, 2 buttons.
Or again, you could write some computer programs that test out the options.
You could.
And they're probably all valid solutions. Thank you,
And how'd
Amanda.
you go with that first one, writing a computer program for that, Jason? You got it sorted?
Yeah. I think Paula makes a good comment in the today's meet chat room. Perhaps we forget to teach strategies associated with problem solving. And like maths, they need a method to help them solve problems.
Yeah, I think the big thing there is also having that method, but actually getting kids to articulate their thinking. Rather than getting them just to solve it, get them to articulate and say, well, okay, what's your thinking process that's actually going on here? So rather than as like a do as I do or as do as I say, really like do as I think and get them to think it out aloud.
Well, that's where if they wrote it out as a computer program, they'd actually be writing through part of the.
But sometimes talking aloud gets you to think through. They go, oh gee, you know what, that doesn't quite make sense. It's a little bit like when kids write an essay or an English assignment, and they'll hand it in. You'll go, have you proofread this? Yeah, sure. Did you read it aloud? No, I just read it in my head. And then when they read it aloud, they go, oh, I see the errors of my way.
Well, you could take a constructivist approach and actually have them make some sort of coin machine that processes things into a steady state. Maybe using marbles or something like that.
Yep.
I'm not sure how it would be how it would look, but it would be awesome. And just like the tricks where you put coins under or balls under a cup and you spin it around, that would be a cool thing to go. I'm starting it like this. Pop, 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 pop. Yep. That's your next homework task, Jason. I like that, Ken. Do you want to talk through what you've just shared with us?
Okay, I'm just doing some rewiring here. Well, an approach we've used with this sort of thing is to get kids or teachers, depending on who you're actually doing this with, to act as the bubbles or buttons or whatever they are. Use some physical objects. Mars bars work pretty well, although not so well with teachers because you never get them back again. And actually give them rules for being whatever it is they have to be. In this case, the bubbles or the buttons, and actually running those simulations live with them, following the rules they have to follow, and they check one another as to how well they follow those rules. It works pretty well as long as the activity is not too geographically complex, because each of them has to be able to see what's actually going on. So if it's in this case, it'll work quite well because you're only dealing with people that would be within a metre or so of one another, or you could run it with them being within a metre or so of one another, and so they'd be able to see what's happening. But if it's too distributed, it's really hard for everybody to see the actual behaviour of the system, which is what we're dealing with here. But in this case, they would be able to see it, and after a bit of messing around, they'd quickly see that what starting processes or what finishing state they want to get, and what the last couple of steps to that have to be, and then by a process of elimination, they probably get their answer out. But it works quite well, and it's a bit more enjoyable than trying to do it entirely on paper, and you'll get different kids that contribute in different ways.
Mm. Oh, Roland.
Jenny, I can see you're talking, but you're currently muted. Do you want to unmute and quickly? Yes,
Is that better?
Yes, we can hear you.
I've been getting my little preps to actually be B-bots, and one person is the B-bot and the other person is the programmer, and they have their clipboard and pencil, and they write the code, and then they tell the B-bot where it has to go, and the B-bot has to follow the instructions exactly. And
Does the
they love
B-bot
being
say,
a B-bot.
I don't know how to do whatever if they get the syntax wrong?
No, it says, but when it finishes, it goes beep, beep, makes a noise. And the kids love being both the programmer and they love being the B-bot, so it really works well. They love to swap over and have a turn of each. So they have a
Do you
great time.
blindfold the B-bot?
No, we don't blindfold the bot. Health and safety.
I don't know what 6 sadistic teacher would do that, sorry.
Have you done that before, Wes?
No, not at all.
I wonder what Ken was asking. You posted the question, could you do this task with if this then that? Which task are we talking about, Ken?
Hang on, see if I can get my wiring working again. The task with the buttons and the bubbles, whether you could actually make that work in using an if this then that recipe of some sort. Whether you could build the pieces of it and use that to actually get a solution to it.
So instead of coins, you can make a perpetual spam email system.
Or something, yeah. I'm just wondering. It seems like it's simple enough to be modelled in something like if this then that, but I don't know whether it'd be possible or not.
Well, that must be your homework task.
Remember too, Ken, my first programming language was analog based. This was using capacitors and resistors to try and simulate and model things. It wasn't a digital computer. And that analog computer sometimes had a resolution that was much greater than the 0 to 255 that we had for the digital computers. It also meant that some of the computers, in the way they operate, don't have to always require having some sort of digital content. In my new car, the speedo actually is an analog which tries to simulate what the digital number is, because my dashboard really is a digital dashboard. We don't have a direct wire that spins around that actually shows you what the speed of a car is. And I think there's some scope towards thinking beyond just simple programming languages and letting kids actually play with resistors and wires and circuits and look at the kind of analog computing that we call electronics.
Speaking of analog, Jenny, you had, well, not really, that was a poor segue, and you had some examples that were kind of board gamey with your students. I know you have to leave soon, so I just want to give you an
Yes.
opportunity to share some of that
Yes.
if you wanted.
Yes. Can you put the pictures up, or do I put the pictures up, or?
I will do that for you.
Hand the camera.
I bought a couple of board games on Kickstarter called Robot Turtles, and it's a board game that's actually broken all world records of being supported in Kickstarters. I think they've made enough money just in Kickstarters to keep themselves afloat for quite some time.
Awesome.
And it actually has cards, and the whole thing's a board game. And you have your 4 turtles, 1 on each corner, 4 players. And you have crystals in the center, and they have to get their turtles into the center to get their crystal. And you can see by the cards there that the cards, there's a forward card, a left turn card, a right turn card. So they put them out in the directions that they want their turtle to go, and each one is a turn, and it's each person getting into the middle. And they all had their cards in different ways, and one of them even looked at his cards and said, "Oh, I can see a pattern there. There's 2 forward, 1 left, 2 forward, 1 left," and he could see a pattern in his programming. So it was really evident and so easy to see the patterns and things that they'd made in their programming to get their turtle from the corner space into the centre to pick up their crystal. And that was the basic level of this game, because then there are different blocks you can put on the board game that you have to go around and detour and do all sorts of things. So the kids loved it though. Robot Turtles it's called, and it's meant for preschooler, prep sort of age children, and they loved it, so that was great.
Awesome.
Fascinating.
Did you want to show any of your other examples, or do you have to fly?
What was the other one I had? The other one was we used the Bebot app on the iPads. So as well as having the actual physical Bebots, there's a Bebot app you can use. And my students love playing in the app, and as well as getting to the actual end of where you have to take the Bebot up to the flower, it times you, so that you get a time for how long you took to work it all out. And then they go back and try and beat their own time, which is really great. So they're competing against themselves, plus they get put on a leaderboard, which they love to see and see everyone's times and see if they can get in the top 3. But I get them to take screenshots of that and put it into Book Creator. Have you got a screenshot of the one in Book Creator? I think it was the one that was upside down that you turned up the right way.
Just grab it.
And then they've been able to, they've been able to look at the screen of the Bebot now, and then they will write the code, and they'll type in the code of where the Bebot has to go. And can you spot the error in this coding? Can you find the bug? Because there's a bug in that one. So
You've gone
that's
far,
what they're doing
far forward.
Forward 3. It's a 3.
Yeah, it shouldn't be a 3. Went too many forward. Whoop, off the board. But anyway, they sat with whiteboards and wrote out the code while someone had the screen and they could see it, and then they took screenshots and put it into Book Creator and typed it up nice and big so we could see it, which is great of them. And so they could, do their very simple code and put it, and then they'd actually show someone else and say, does this work? And they put it on the Bebot on the iPad and do it, follow the instructions that were written and see if it worked or not. So it was a great fun they had. And again, one was the programmer and one was doing the instructions, which they love, working in partners and collaborating together.
That's so cute. I love that mix of physical and also with the Bebot kind of side of things as well. That's cool.
And the good old whiteboard markers and the little whiteboards.
Absolutely. Ken has asked if the Bebot app lets you transfer the program back to a Bebot, or is it just separate?
No, it's all on the iPad. It doesn't transform back to the Bebot. You don't control the Bebot with the iPad or anything. Not like the MIP robot that I've just ordered. That'll come in a few weeks' time. That allows you to actually program in on your iPad or iPod or something using Scratch-like blocks, as in Scratch, and then your robot becomes gesture-based. So you can wave at it, you can clap at it, you can do all these different things, and depending what gesture you use, it will do certain things the robot will do. So it'll be a lovely little robot.
Oh, that sounds fun. I look forward to you sharing us with that in the future. That with us in the future.
Well, I have to go, so thanks for having me.
Thank you so much.
And enjoy the rest of the conversation.
We will.
I'd like to close, Amanda, if we can. Wes has got his robot there. Have you had a chance to showcase that yet?
Oh, my Romo?
Yes.
So I don't have the iPod on it, but effectively you put an iPod on and it then uses the camera as a, sort of basically like a looking device, and you can interact with the robot. You can then use your iPad then to interact with it, and then you can use that as a mobile robot to drive through, and you can see where the robot is using the camera on the iPod itself on your own iPad. So you can say, like 10 years ago, this is exactly what the police used to drive into a house to see if there were any explosives or whether it was a safe place or not. And now here we've got it for $150. The kids can start doing those sort of things in their own classrooms.
On there, we didn't have
iPods.
But I know that I have a task list called Chore Wars that I use with my kids to watch them and make sure they clean up their bedroom and they complete that. Now I've got a device I can stick my phone on and have a look to see if they've actually cleaned the socks out from under their beds. Well, it's been a wonderful talk tonight, and I guess we could talk all night, but we need to bring it close to what we've been doing. And I just want to invite each of our guests perhaps to give a bit of a speak to kind of things that they've learned. And just starting from left to right, we could talk a bit about what we've learned tonight and what you'd like to share. You'd ask questions.
And again, Janine will give you some time to type in some reflections, and one of us will read that on your behalf.
Perhaps starting with Jason.
I think it's always good to speak about various stuff to do with digital technologies and computational thinking. The other thing I'd like to see with these approaches is taking it the next step where we actually start using the technology, as Semour Papert was such an advocate of, and instead of doing them as conceptual problems or mathematical paper-based problems, actually using devices to make them into reality.
That's a good point. Ken.
Okay, what I've learned, amongst other things, I better get this microphone fixed. But certainly, I'd agree there with that concept that we really need to start to see some of this stuff being, actually happening from a constructionist point of view. I guess the big plus is we now have a curriculum that, an Australian curriculum that's going to have some support and some resourcing attached to it that will allow a large number of teachers to play in this space. And we're now dealing with technology that's relatively cheap and probably, buyable from your local chain store. So I think it's an interesting time, really, from the point of view of the sort of things that Papert originally envisaged, and hopefully the old guy will recover and get to see some of these things happening. It'd be really very, very worthwhile.
Thanks, Ken. And Wes?
Yeah, I think with Papert's work, it's interesting that with the work that was done by him, we seem to have we sort of lost sight of him during the 90s and the noughties, and have sort of come back around to his way of thinking these days, and I'm glad about that. And I think Ken sort of mentioned about the if then then that sort of process of using that sort of technology to start to use that in terms of the computational thinking, where the kids can actually create some very useful recipes to get some very useful data for some very real problems that currently exist. And I think that that whole Internet of Things is going to be a really interesting landscape in the next couple of years.
Thank you, Wes. And Janine.
Oh, excellent. I'll read Janine's. It's been a good trip down memory lane. The new curriculum is like a coming of age and formalization of things that were popular back on the, but on the edge back in the 80s. The link to literacy is also interesting, as is the idea of working in partnership with technology. Love it. Thanks for sharing your reflections tonight as well, Janine. It's been great.
He's an IT pioneer. We're really privileged to have all of you guys on board. And Janine, I remember the first time I caught up with you doing the first webcast in the 1990s. Working on the edge really got me thinking about being able to do collaborative stuff. Consider it now. I'm meeting you now, and we're doing this regularly. And you laid down those experiences for me way back in the 1990s. I think it was 1996, 97. So, bravo. For me, Amanda, when I'm thinking about the different threads that I guess I've kind of gleaned from tonight, there's so many different things that Papert inspired me with. I have to keep revisiting the kind of vision that he has, and it's really quite complicated. I need almost maybe 100 lifetimes to sort of get all of these bits and pieces together. It's good that we're revisiting it, because there's no one simple way of being able to distill how we can best guide students in their learning. One thing that is consistent is that the way kids learn probably is the same. It's just the kind of ways we can employ tools to stimulate, encourage, and inspire. That's what we're kind of fine-tuning, and that's the craft of education. It's what we are about as teachers. I like the point that Jason made. It's not just about coming up with better pencil paper tests as much as being able to use some of these computational tools and being able to motivate kids to explore, invent, build, construct, and at the same time, by that learning, develop their ideas and develop their thinking. So it's been a really good journey for me. It's maybe 2-3 decades, and I'm still coming to understand some of the work of Papert and his legacy. I don't think we can do justice in one show, and I'd encourage anyone to have a look at some of his papers and have a look at some of his books. And I'll close on that and turn to our lovely Amanda.
Thanks, Roland. I've certainly really enjoyed our hangout this evening. I'm probably a little newer to Papert and to this kind of thinking and ideas than the rest of the panel members. But I think it's been really fascinating for me to make some more of those historical connections and building on my experiences as well. I love that tonight we had some practical elements both in what we did and in terms of just the stories that were shared by people in terms of making those real world connections and the things that students have created and coded and developed and the thinking that goes around that. So thanks everyone for coming along. I hope you had as much fun as we did. Now next week in our ACCELN broadcast, we're going to be checking in with some of the digital leaders who will be at the ACEC conference and exploring the place beyond student voice of student action within learning as well. So I'm really looking forward to that. Hopefully I'll get an event invite and information on our Wikispaces page in the next few days. If you'd like to be part of our panel for that session, please let us know. And remember, you can view all of our past Hangout recordings at acceln.wikispaces.com. Thanks so much. We'll see you next time.
Thank you very much. Thank you everybody for the Hangouts and in the back channel room and Paula. And we look forward to seeing you then. Bye, Anne.